that bone-chilling cry. Doesn't it just get your heart racing? Hello, and thank you for visiting the Research Commission, where we use biology and chemistry to explain our favorite video game monsters. I am Professor Argentum, and this is my new apprentice, Poco.
Hello.
Today I asked a hunter and my assistant to retrieve a Legiana for me to study. Legiana is a flying wyvern with an average size of 1,810 centimeters. It utilizes ice element in its attacks, and is weak to fire and thunder element. Its blue dorsal side and tan ventral side act as effective camouflage as it flies through the skies. Legiana is seen feeding on raffinos, picking them straight out of the air. And although it's an apex predator, it's often seen fighting with Palumu and Aldogaron over territory. Its main strategy for hunting is freezing its prey with chilling winds to prevent their escape. You're right. That was some time ago that I sent Rena and my assistant on their quest. I feel like they should be back by now. I should probably check in on their expedition team. Let's go, Namako.
Should I come too? Professor, wait!
Captain, look! The raffinos!
They're getting restless. Something's wrong. It's here.
What is that?
Wait, get back! That's what we've been looking for. Legiana.
How are we supposed to bring that thing home?
Captain, land this ship.
You got it.
Let's go find that monster.
Wait, look out!
Welcome back, Rena. Good job bringing this back here. What a fine specimen. You even brought it back alive this time.
Yeah, well, it wasn't easy, Professor Argentum. I almost got carted twice.
Well, I appreciate your efforts. This will go a long way in our research.
Cool. Have fun. Oh, I wanted to ask you something. When fighting Legiana, I noticed it has this ability to freeze everything around it with its attacks. How is that? Is it using some kind of Blizzaga spell or something?
Well, tell me, Poco. What do you think is going on?
Well, perhaps the air is so cold in the coral highlands that when it flaps its wings really hard, it just freezes everything? Or maybe it has something to do with air pressure. I don't know.
That's not a bad theory. But see, this is a great example of the importance of going out to the field to do research. Rena, what's wrong with her theory?
The coral highlands is warm. Like, tropical. Even on top of the mountain, there isn't any snow. So, Legiana can't just be whipping around already cold air. There's gotta be something else going on.
Exactly.
Okay, that makes sense. What are some other theories?
Some people seem to think that Legiana has ice breath, but I say those people just aren't paying enough attention. Never during the fight does it focus a breath attack on you. Its ice attacks come from its wings and tail. Another theory came from a friend of mine. She hypothesized that perhaps Legiana sweats out ice and shoots it at you. To that I say, Legiana does not sweat. The purpose of sweat is to regulate body temperature, and birds do that by evaporating water around their lungs, essentially exhaling the heat away. But I believe she was on the right track.
So what's your hypothesis, Professor?
Alright, first, look closely here. Do you see these teal scales? Those scales cover up secretory glands that act as blowholes. It uses them to... What?
So Legiana's a whale?
No. Many animals have evolved with orifices to eject fluid. Look at the spitting cobra. They have holes in the front of their fangs connected to venom sacs. They're able to spit their venom through these holes up to 2 meters.
But it's not like Legiana is blasting water out of a blowhole. It's blasting super cold air.
Well, not quite. Take a look at this. Inside Legiana, there are 3 different kinds of sacs. Frost sacs, freezer sacs, and cryo sacs. Each of these sacs are filled with a powerful freezing agent, not just cold air.
Oh, I get it. So what is this freezing agent?
Pogo?
Liquid nitrogen?
Yes, liquid nitrogen.
Seriously? Where does it get liquid nitrogen?
From its blood. I told you this thing is a masterful work of art.
Okay, you're gonna have to explain that.
Sure. Let's start with the fact that if it's spewing liquid nitrogen, it's first going to need an abundance of nitrogen to begin with. Fortunately, it maintains that surplus of nitrogen quite easily. First, Legiana is seen feeding on raffinose. During digestion, that raffinose meat gets broken down into its macromolecules. The protein in that meat gets further broken down into amino acids, the basic building blocks of proteins. In the liver, amino acids are converted to ammonia and urea, 2 molecules constructed around nitrogen. Those molecules are ejected back into Legiana's bloodstream.
But that protein is also needed to build muscle. Is that going to be enough nitrogen to supply all those sacs?
You are correct. But that is where the second method comes in. Poco, where else can Legiana acquire nitrogen?
I don't know.
Remember this. Organisms are the summation of the environment that they evolved in, and Legiana is no different. The coral highlands lies atop the rotten veil, literally a rotting biome steeping with nourishment. When things rot in the veil, their decay releases nitrogen into the air. As that air rises, it fills the atmosphere in the coral highland. Nitrogen is already the most abundant gas in our atmosphere, at around 78%, but is even further increased in the highlands from the veil. With every breath Legiana takes, it inhales nitrogen-rich air, supplying the bloodstream with even more nitrogen that again gets converted to ammonia. Combined with the protein from the meat it ingests, and the ammonia it makes naturally from the breakdown of its own amino acids, the Legiana has ample nitrogen to pull from. So now, this ammonia is running through its bloodstream. Some of it is filtered out into the kidneys, but more of it is filtered into the eye sacs. As the blood passes the eye sacs, ammonia and oxygen diffuse through pores in the blood vessel. On the surface of the eye sac, a special protein, aquaporin 8, is concentrated. This aquaporin carries ammonia into the first part of the eye sac. In this first layer of the eye sac, special cells take oxygen and use it to convert the ammonia into water and nitrogen gas. This chamber of the eye sac is filled with an organically formed clinoptilolite, substance known as a zeolite, whose chemical makeup attracts nitrogen. More transport proteins move nitrogen gas into the second chamber of the eye sac. Filled with this nitrogen gas, the secondary chamber expands to lower its pressure significantly. As it does that, the nitrogen gas absorbs to the eye sac, creating a thin layer of liquid nitrogen. The liquid nitrogen seeps through the membrane and collects in the final chamber of the eye sac. The second chamber reduces in size, returning the pressure inside to normal levels, ready to receive more nitrogen gas. The tertiary chamber has an aperture that opens to the outside. So when Legiana is ready to attack, it opens the aperture, contracts the tertiary chamber of the eye sac, and liquid nitrogen is ejected. Once the nitrogen comes in contact with warmer air, it immediately begins to boil. However, it is still cold enough at this point to freeze things on contact. So with the whip of its tail, or powerful flap of its wings, this half-gaseous, half-liquid state of nitrogen becomes a projectile to freeze its prey or aggressors.
Cool. Sounds chill. But that leads me to one more question. If Legiana has liquid nitrogen just sitting around in its body, how is it not freezing itself and damaging its own body tissue?
That is an excellent question. I want to present you with two pieces of evidence. The first, nototheniioids, a group of fish that live in Arctic waters. These fish have a myriad of evolutions that allow them to survive frigid temperatures, but one of them is a special antifreeze protein. These proteins bind the ice crystals and prevent them from gathering and damaging tissue. The second example is various invertebrates, like Homunculus contortus, Neposhongulus brasiliensis, and Ostrotachia circumcincta. These invertebrates have been known to survive frigid temperatures of liquid nitrogen with a host of different cryoprotectants. One method they employ to protect themselves is replacing freezable and damaging water with another chemical called glycerol. This glycerol does not form ice crystals in the organism's tissue like water does. Legiana has evolved to utilize these tools well. Antifreeze proteins are highly concentrated in the ice sacs and the tissue surrounding it. In these areas, glycerol is used in the chemical makeup of these tissues in place of water. With these advantages in place, the Legiana is only going to freeze the things it intends to, like you.
That's actually really cool. Thanks for the info, Professor. If you'll excuse me, I need to go get warm. I still can't feel my toes.
Researching these monsters is not easy. It is important to learn a lot more about the environment and evolution to understand how these monsters came to be.
Okay, I'll start researching right away.